Today we're diving into building a dynamic confetti animation in Flutter. Perfect for celebrations, gamified rewards, or simply making your app more fun and engaging. First, create a new Flutter project. After creating the project, open the main.dart file and replace its contents with a basic setup. Now let's create Confetti Animation widget. Create a new file, confettianimation.dart. The Confetti Animation class manages the confetti particles, their positions, velocities, and shapes. The state class mixes in the single ticker provider state mixin. This mixin provides us with a way to create a single animation controller for our widget. Here we define some variables, animation controller for the confetti, list of offsets to define the list of particles, list of color to define the color for each particle, horizontal and vertical velocities, and list of shapes defining the shape type for each particle. The shape type class is a simple enum that defines the different shapes our confetti particles can take. We have circle, rectangle, and triangle as options. In the init state method, we initialize our animation controller. Think of this controller as the conductor of an orchestra. It controls the timing and playback of our animation. We set the duration property to 5 seconds, which means the entire animation will last for 5 seconds. The vsync property is set to this, which basically tells the animation controller to synchronize with the Flutter framework's rendering ticks for smooth performance. We then set up 2 listeners for the animation controller. The first listener is called on every frame, or tick, as the animation progresses. We use the addListener method to define what happens on each of these ticks. Inside the listener, we call setState, and this will trigger a call to the updatePositions method, which we'll discuss in a moment. This way, the animation is continuously updated and redrawn on the screen. The second listener is attached using the addStatusListener method. This listener is specifically called whenever the animation controller's status changes. We're interested in the animation status.completed state, which means the animation has finished playing. When this happens, we clear out all our confetti particles. We set the positions, velocities, and shapes lists back to empty. We do this by calling setState again, which tells Flutter to redraw the screen with the confetti cleared away. This ensures our animation doesn't leave confetti particles behind after it's done. Finally, we set up some empty lists to store the positions, colors, and shapes of our confetti particles. In the dispose method, we properly dispose of our animation controller to avoid memory leaks. Then we have the start animation method. This method is called when the user taps a floating action button, which we'll add in the UI later. This method essentially populates our empty lists with data. It creates 100 confetti particles using list.generate, assigns them random starting positions in the center of the screen, and gives them random horizontal and vertical velocities. The velocities_list holds the horizontal velocities for each particle. For each element, we generate a random number between -0.5 and 0.5 using random.nextDouble. We then multiply this random number by 8 to give our particles some initial horizontal speed. This will make them move left and right in a more natural way. Similarly, we create the velocities_y list. This list will hold the vertical velocities for each particle. We generate a random number between 0 and 1 using random.nextDouble and then multiply it by 16. The negative sign gives the particles an initial upward thrust, creating the explosion effect. Finally, we create the shapes list. This list will determine the shape of each confetti particle. For each element, we randomly select a shape from our shape type enum. We do this by using random.nextInt to get a random index within the range of the shape type enum values. Now that we've set the initial positions, velocities, and shapes for all our confetti particles, it's time to start the animation. We call controller.reset to ensure the animation controller is in its initial state. And finally, we call controller.forward to start the animation. This will trigger the animation loop, and our confetti will begin to fly across the screen. So, that's the start animation method in a nutshell. It's like setting up all the fireworks before the big show. We've positioned the fireworks, set their initial trajectory, and given them some random twists and turns. Now, let the animation begin. Okay, let's dive into the updatePositions method. This is where the real magic happens. This method is called repeatedly by our animation controller, like a heartbeat, keeping the confetti animation alive and flowing. Imagine this method as the choreographer of our confetti dance. It's responsible for constantly adjusting the position and movement of each and every confetti particle. First, we create a random object. We'll need this to add some unpredictable twists and turns to our confetti's flight path. Then we enter for loop. This loop will iterate through each of our confetti particles. We have a list of 100 particles, so the loop will run 100 times. Inside the loop, we start by updating the position of the current particle. We use the offset class to represent the position of the particle. We calculate the new x-coordinate by adding the current x-coordinate, positions i.dx, to the particle's horizontal velocity, velocities x, I. We do the same for the y-coordinate, adding the current y-coordinate, positions i.dy, to the vertical velocity, velocities yi. This effectively moves the particle according to its current speed and direction. Next, we apply a touch of gravity to the particle's vertical velocity. We add 0.3 to the velocities yi. This simulates the downward pull of gravity, making the confetti particles gradually fall back to the ground. We've slightly reduced the gravity here to make the fall a bit slower and more graceful. To add some extra flair, we introduce a bit of randomness to the horizontal velocity. We generate a random number between -0.5 and 0.5 using random.nextDouble and add a small portion of this random value to the velocities x, I. This creates a subtle wobble in the horizontal movement of the confetti, making it look more natural and less robotic. And that's it. This update positions method runs continuously as the animation plays, updating the positions and velocities of all the confetti particles, creating the beautiful and dynamic confetti effect that we see on the screen. Okay, let's look at the build method now. The body of the scaffold uses a stack widget. This allows us to layer multiple widgets on top of each other. The first child of the stack is a center widget. This widget positions its child, which is a simple text widget, in the center of the screen. The second child of the stack is the CustomPaint widget. This is where the magic happens. The CustomPaint widget allows us to draw custom graphics onto the screen. We provide the size of the CustomPaint widget, which is the size of the current screen, obtained using Media Query. The most important part of the CustomPaint widget is the Painter property. We set this property to an instance of our Confetti Painter class. This is where we tell Flutter to use our CustomPainter to draw the confetti particles onto the screen. We pass the positions, colors, and shapes lists to the Confetti Painter, so it knows where to draw each particle and what color and shape it should have. Finally, we have a floating action button at the bottom of the screen. This is the button that triggers the animation. When the user taps this button, the Start Animation method, which we discussed earlier, is called. This initiates the confetti explosion, and the animation begins. Now let's break down the Confetti Painter class, the artist behind the confetti magic. This class is responsible for taking our confetti data and translating it into beautiful visuals on the screen. Here's how it works. First, we have the constructor. This is where the artist gets their supplies. We pass in 3 lists: positions, colors, and shapes. These lists hold the information about all the confetti particles that the artist needs to paint. Then we move on to the paint method. This is where the real artistry happens. Here we use a paint object, which is like the virtual paintbrush. We can use this paint object to set the color and other properties of the paint they'll use to draw the confetti. Then we define for loop. We need to loop through each position and paint the corresponding confetti particle at that location. Inside the loop, we first set the color of the paint using the paint.color property. We use the modulo operator, % to get the color for the current particle by cycling through the colors list. Now comes the fun part, drawing the confetti. We are using a switch statement based on the shape of the current particle. If the shape is a circle, we use the canvas.drawCircle method, in which we provide the particle's position, a radius of 5, and the paint object to draw a perfect circle. If the shape is a rectangle, we use the canvas.drawRect method. We create a rectangle object from the center position, width, 10, and height, 10 of the rectangle, and then use the paint object to fill that rectangle on the canvas. If the shape is a triangle, we use a path object to define the triangular shape. First, we move the path to the top point of the triangle, based on the particle's position, then draw lines down to the left and right corners, and finally close the path to create a filled triangle. We then use canvas.drawPath to draw this triangular path onto the canvas using the paint object. After looping through all the positions and drawing each confetti particle, we are done. We've transformed our confetti data into a beautiful and vibrant animation on the screen. The should repaint method tells Flutter that it will always repaint themselves whenever the data changes. This ensures that the confetti animation stays up to date as the particles move around the screen. And that's the Confetti Painter class. It's the invisible artist behind the scenes, bringing our confetti animation to life. And that's it. We've successfully built a dynamic and engaging confetti animation in Flutter. We've learned about creating animations, using the AnimationController, manipulating particle positions and velocities, and drawing custom graphics on the screen. If you found this video helpful, check out other Flutter animation videos on my channel. Until next time, keep fluttering.